All right. So almost there.
Hello, sir.
Hello, Afan and Ali. Okay, please do check your tests, okay, and see the mistakes, please, okay, and do let me know if you have any problems still. I'll help you with that. Anyway,
No, sir.
okay, let's start with the thermal properties that we're basically aiming at today. Still not started. Okay. Now, so thermal property, the first thing I would like to tell you um, is about the temperature, really. Okay. We did solid liquid gases, right? Let me see if we have done kinetic model theory. Okay, no, we first need to do that and then we can go towards that. Fine. So, in the first part of thermal properties, we are going to learn about kinetic model theory. In kinetic model theory, we're going to learn about solids, we're going to learn about liquids, and then we're going to learn about gases. So basically, the arrangement that you see in solids are like this. They're arranged at their fixed positions and they just vibrate there, they don't move. In liquids, they are in groups or layers, and in gases, they are randomly moving at fast speeds. Is it clear, everybody? Now, so solids have fixed shape, fixed volume, very strong intermolecular forces, and increase in temperature when you heat it up, okay, causes stronger vibrations in molecules at fixed places. Is it clear, everybody? Now, liquids have no fixed shape. So basically, if you put them into a container, it would take that shape, and but it has a fixed volume. It does have strong intermolecular forces, not as strong as solid, but quite weak from that, but still strong. And when you increase the temperature, the vibrations increase. Also, molecules can move between layers. Is it clear, everybody? Now, gases have no fixed shape, they have no fixed volume, because they can take, if you put them in a can, that's their volume. If you release them in, in a room, that's their volume. because they have little to none intermolecular forces. Now, increase in temperature causes the molecules to move at higher speeds as their kinetic energy increases. Is it clear, everybody? Any question here? Please let me know. All right. All right, everybody's written this. Zainab, Tamushi, Ali, Caroline. Who else is here today? Hussein. Okay.
Yes, sir.
All right. Hussein, I'm really angry at you, I'll tell you at the end why I'm so angry at you. Okay, now, so what you guys need to understand is that okay, so what you guys basically must remember is that when you go from a solid to liquid, this process is called melting. When you go from liquid to gas, this process is called boiling. When you go from gas to liquid, this is called
Condensation.
yes, very good. And when you go from liquid to solid, that is called freezing.
Freezing.
Well, we can also go from liquid to solid in another process that is called evaporation, and I have not included it yet because we'll do it. Don't worry. Okay, now. So,
Sir, evaporation?
yeah, evaporation is going from liquid to gas as well.
Doesn't it go from liquid to gas?
Yes, liquid to gas. That's what I'm saying.
Oh, I thought you said to solid.
No, liquid to gas. Okay, boiling and evaporation both does the same thing, but they have a very major difference between them. Okay.
Okay.
All right. So first of all, we are now going to look at what exactly do we mean by temperature. Okay. So when I say temperature, temperature is defined as the measure of how or hotness or coldness of a substance. So either you can write this or you can say temperature depends on the average kinetic, let me write full, kinetic energy of particles in the system. So if the average kinetic energy is higher, it means the temperature is going to be more. If it's lower, then the temperature is going to be less. Is it clear, everybody? In our course, we're going to learn about two different scales. So first of all, we're going to look at Celsius scale. Celsius scale is basically symbol is Celsius is degree C, and Celsius scale is one of the units we're going to look at. The other one is the Kelvin scale. The difference between the Kelvin scale and the Celsius scale is that the Kelvin scale is called the absolute scale of temperature. Also, this scale basically is called thermodynamic scale. Alright, we don't really need to know that word, just I'm telling you because it's good to know that. Now, let me tell you what it means. In a thermodynamic scale or absolute scale, basically the two are related in such a way that the temperature in Kelvin can be found out if you add 273 to temperature in Celsius. Is it clear? And this is the formula that you need to remember all the times. Now, so if I say I want to know the melting point of water in kelvins, so do you guys know the melting point of water in Celsius?
0.
0. So what you're going to do is you're going to write temperature in Kelvin equals to 0 plus 273. It means in Celsius scale the temperature is 273 Kelvin, which is equivalent to 0 degrees Celsius. Understood? Okay, now then you got, if I say okay, I want to find the boiling point of water in kelvins, then the temperature in Kelvin could be, what is the temperature of boiling of water in Celsius? Anybody knows?
100 degrees Celsius.
100. So we're going to write 100 plus 273. That would mean it is 373 kelvins. Is it clear, everybody? Any questions? Now, so with that, we can actually talk about the absolute zero temperature. Absolute zero temperature means that it is basically the temperature at which minimum kinetic energy is present in molecules of a body. Now, absolute zero temperature basically means 0 kelvins. Do you guys understand this? Okay, so have you ever tried to know what is the temperature of the freezer compartment of your fridge? Anyone? Where you store food so you can use it like later. You store meat, sometimes vegetables, sometimes frozen items, fish, etc. Anything. Do you know what is the temperature there? Nobody knows in this class. Afan, don't you know Zainab? That's not fair. Nobody knows Caroline? Don't you know? Okay. The fridge is basically from 18 degrees Celsius and sometimes it is minus 25 degrees Celsius. And that's so cold that basically your food does not go bad in couple of weeks or months, right? But now we look at what is 0 kelvins in Celsius. So the temperature, we're going to write temperature in Kelvin, we're going to write the formula. That's 273, and we want to know what is 0 Kelvin equivalent to degrees Celsius. So basically in degrees Celsius it is going to be minus 273 degrees Celsius. Imagine how cold that is. Do you understand? So this is the least amount, the smallest temperature you can reach. And that's why it is called absolute zero temperature. Is it clear, everybody? Okay. No, -4 is the temperature. Well, it's not. Well, it is 4 degrees. Usually 4 to less than, actually greater than 0. Tamoshi, the reason fridge is kept at 4 degrees because if fridge is kept below 0 degree, then most of the things in your fridge would freeze, and you don't want that, right? You want it to get cooled, not to be frozen, right? But in the freezer compartment it is minus 18 to 25 minus. Is it clear? All right, now let's move forward. So basically now we are going to go towards gases and their behavior when we look at them in general thing. Okay. So before that we should move towards Brownian motion. So Brownian motion is basically this scientist Brown, he actually carried out an experiment where he saw the behavior of freely suspended gas or liquid particles. So he put a microscope, he put light, and then he added smoke and air particles inside a container like this. Now the reason of adding smoke particles was that smoke particles have color, so they can be seen in the okay. Now, so what they observed was that the smoke particles were seen going randomly in erratic movements everywhere, sometimes hitting the neighboring particles, sometimes just hitting the walls. Is it clear? So he said basically in free suspension means that they are not attached to anything, they can freely move. In free suspension, the liquid or gas particles move erratically in all directions, colliding with neighboring particles and walls of the container. Understood? And this is why Brownian motion provides evidence of kinetic model theory, that basically they have kinetic energy and they're always moving here and there randomly. Do you guys understand this? Now, so just I want to write a note here that you guys should remember. When we are talking about particles, basically we mean that we are talking about the microscopic particles, and microscopic particles can be regarded as atoms or molecules. Is it clear, everybody? So do not write mass, do not write anything else, okay, gas or something. Just always use the right terminology, because that is very, very important. Okay, should I go forward then?
Yes.
Okay, now we are going to now learn about the temperature and pressure relationship. Now I just want to clear your concept. Basically, when you see a container like this, if this is a gas molecule we are looking at, so when the gas molecule basically moves with a certain amount of speed, it hits the container, and when it hits the container, it causes basically a force to be applied on it. Is it clear? When the force is applied, so basically this force is applied on a certain amount of area, because there's so many particles, so this causes pressure on the walls of container. Do you understand? So we can say when particles hit the walls of container, they cause a force per unit area that causes pressure to be exerted. Any questions about it? Now, then what happens? The question remains, what happens if temperature of gas is increased? So the answer to this is that when temperature increases, the kinetic energy also increases, as we've learned previously that temperature depends on the kinetic energy. If the kinetic energy increases, the speed of molecules or atoms, whatever you want to write, also increases. So they hit at faster speed causing greater force, which increases pressure. Is it clear, everybody? So that means that increasing increasing temperature Okay, so basically that actually means that increasing temperature also increases pressure for constant volume of container. Is it clear, everybody? Any questions? Anything you did not understand, please let me know. Please write this down. It's very important. Okay. Done. Should I go forward then? Tamoshi, Ali, Mohammed. Okay, good. All right. Now, so then we can also talk about the relationship of pressure and volume relationship. And this was basically given by a scientist whose name was Boyles, and he has presented a law, right? The other one, the temperature one, basically was given. Let me write it so that you guys don't forget. It was given by Charles Law. Okay, so you don't really need to remember the law names, it's fine. So what you're gonna do is you should remember that in Boyle's law he says that the pressure is inversely proportional to the volume provided that the temperature remains constant. All right, in that one, basically in Boyle's law, temperature and pressure were directly proportional if there was constant volume. In this, pressure and volume are inversely proportional if it's constant temperature. Is it clear, everybody? Okay, let me write it here so you guys should know. Temperature, please add it so don't forget. Temperature and pressure are directly proportional provided the volume stays constant. Okay, please write this and then we're going to move forward. Okay, now here the pressure is inversely proportional to volume provided the temperature remains constant. Okay, now basically Boyle's law states that this pressure is inversely proportional to volume if the temperature is kept constant, which means that if I resolve this, can I say, if I remove the proportionality sign, I have to put a constant here. Constant is K, suppose. So I can write that P times V is equal to K, which is a constant. Is it clear, everybody? So, if comparing the same gas at different conditions, when I say maybe the pressure changes or the volume changes, so you can write that P1 V1, this is the first condition and the same volume, equals to P2 V2 because the constant will stay the same. So ultimately we're going to get an equation which is P1 V1 equals to P2 V2. Is it clear, everybody?
Yes, sir.
Okay, now, so when we're looking at these two, the Charles law and the Boyle's law, in graphically, so I just want to tell you, whenever there is going to be a direct relationship, that would mean that if you have pressure on this side, if you have temperature on this side, so it would show you a straight line like this. So this is a direct relationship. In direct relationship, remember, the graph always starts from the origin and it is a straight line. Okay. In Boyle's law, because it is between volume and pressure and they are inversely proportional to each other, which basically means if you have pressure here and volume here, so it would show you a graph which is like this, a downward curve. Is it clear, everybody? This is direct proportion and this is inverse proportion, and for all these proportions basically this is the same thing. Any questions? Now let's do a question then and conclude this class. It says a gas at 600 Pascal has a volume of 20 centimeter cube. What will be its volume when the pressure is increased to 800 pascals? Can you do it? Try this, please. Okay, any answers? I think you should have gotten the answer.
Sir, I got 50.
15 centimeter cube. Okay,
Yes.
Answer 26.6.
you got 26.6. Who got 26.6? Mohammed?
Me, sir.
Okay, Mohammed. Okay, what about Ali, Caroline, Afan? So many people. Zainab, Hussein, .26 points. I don't think 26.6 would be the correct answer. You know why? Because if the pressure increases, don't you think the volume should decrease? You know? I think. So if you try P1 V1 equals to P2 V2, the pressure was 600 times 20 and the pressure was 800 times X. This is what we need to find, the new volume, right? So this would be 600 times 20 divided by 800. So what 15 would, I think 15 could be the right answer. Let me check, huh? Yes, it has to be 15 centimeter cube. Is it clear, Chavez?
Yes, sir.
Okay, Caroline, do you understand everything? Afan, Hussein, Zainab?
Yes, sir.
Okay. Now, Hussein, I want to basically, when I was checking your papers today, right? I was basically quite surprised. Because imagine, do you know what is cam scanner? Hussein? Where was the worksheet I gave you? Mass fit density. Okay, this was the test I gave you. I think I gave you, yeah. Wait, it was the test. Hussein, do you expect me to open each 16 pictures? It's not very easy for a teacher, you know. You know, Hussein? So
Yeah,
you gotta you have to use cam scanner, take the pictures, it will automatically convert it into PDF. Okay? And that makes it so easy because then I don't have to, you know, load every picture. It's very slow that way. Ali, I also want you to basically, you sent me a picture from a very high resolution camera, you know, and I don't know how I opened that. Okay, it was not even saving. That's why I could not send you the work. Do you understand, the checked one? I checked it, but I could not send it. Is it clear? So please start using Cam Scanner. Just an app. You can download it from Play Store or App Store, whatever phone you have. and then you can send it. If you have any questions now, please let me know. Otherwise, we're going to continue this tomorrow. All right?
Sir, in this worksheet,
Huh.
question number 10.
In this, which worksheet? The test.
This one, the test.
The
You
test.
mark.
Question number 10. Okay, let me see what
Yeah.
is that. Question number 10. Yes. What happened?
What is the answer for that?
So basically the mass difference was 20 grams divided by 10. So it should be 2.
Yeah, but sir, in my answer you wrote it's B.
Okay, so probably I made a mistake then. Probably during the checking. You can correct it, okay?
Okay, so
Anything else?